Okay, so here we want to compute a double iterated integral. And in general, when we have a double iterated integral, it should be considered as a routine thing to actually compute it. It should be a routine process. You just integrate from the inside to the outside and compute the integral. In fact, one might argue that when we're given a double integral, what we really need to do is express it as a double iterated integral. So why would we want to change the order of integration for this double iterated integral? It's because if we try to perform the integration, the first integration, we will get stuck trying to figure out the antiderivative of e to the x squared. You know what? There's nothing wrong with the antiderivative of e to the x squared. It perfectly exists. It's just that we don't have a formula for it. So we would have trouble completing the integration. So, so here comes the idea. The idea is that this double iterated integral came from a double integral, and whoever came up with this double iterated integral chose to integrate first with x, then with y. What if we gave it another shot and tried to integrate first with y and then with x? But then here comes the problem. We don't have the initial double integral. All we have is the double iterated integral. And in fact, what it is that we're missing? And the answer is we're simply missing the domain of integration. So the first step in solving this problem is to understand what the domain of integration is. And what we really need to understand is that the first integration takes place with respect to x, right? So it's a horizontal integration, and that means that it has a left boundary and a right boundary. And what is the left boundary? So the left boundary would be x equals y. How do I know this? That's the information from the lower limit of integration. And it has a right boundary, which is what? X equals 3. Now, ask yourselves, what are these two boundaries geometrically? So x equals y, or y equals x, if you like, is the bisector of the first quadrant. So it looks like this. And x equals 3 is a vertical line that goes through 3. So we know that the integration is taking place somewhere between these two lines. But what are the exact vertical limits of this integration? And that we can read them from the outer integral. So we start at 0 and we end at 3, which means that the domain of integration is this full triangle right here. So this is the domain of integration. And once we have this domain of integration, now we can ask if we can reverse the integration. Now, of course, we can reverse the integration for such a simple domain. It's not true that for any domain you can automatically reverse the integration, but for this one, it's very straightforward. And all we have to do now is consider the lower boundary and the upper boundary. If we want to integrate with respect to y, that's what we should be looking for. And the lower boundary is nothing else but the x-axis. And the x-axis is, in particular, y equals 0. And the upper boundary, now we have to express it in terms of x. So we solve for y, so it's y equals x. Now we have everything that we need. So the inner integral is going to be from 0 to x e to the x squared dy. We're integrating vertically. And the outer integral is going to be 0 to 3, because this is the horizontal range of all these vertical integrations. And now everything has changed, because if you want to compute the inner integral, you have absolutely no problem. We're integrating with respect to y, and e to the x squared is a constant. So its antiderivative is simply y times e to the x squared. And we have to go from y equals 0 to y equals x. And this will give us what? It will give us the integral from 0 to 3 of x e to the x squared dx. And again, we understand that everything has changed because now we have this extra x and we can perform a substitution. So u is equal to x squared, du is equal to 2x dx, or x dx, which is exactly what we have, is equal to 1/2 du. So this, I put the 1/2 outside, and I have the integral of e to the u du. And what we have to remember is that we have to also apply the substitution on the limits of integration, meaning we take 0 squared, which is 0, and 3 squared, which is 9. And now we perform our integration. And that's going to be 1/2 e to the 9th minus e to the 0, which is 1. And this is our final answer. And that's all. Thanks for watching.